Hey guys, welcome to this video lecture series on the subject of energy technology. I am Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. In previous video, we have started the fuel and combustion topic in the chapter of energy efficiency in thermal utilities. Well, we have covered the topic of preparation of coal and proximate analysis of coal. If you have missed that video, you can find that in the I button over here. Now, in this video, we are going to start the ultimate analysis. So, let's get started. Well, the ultimate analysis provides the convenient method for reporting different major organic components present in the coal, or we can say that it helps to find the composition of coal. Well, for this analysis, a sample of coal is being kept in the ultimate analyzer, where we measure different components that are present in the coal. Well, this determination of different components includes the percentage of total carbon, then the percentage of total hydrogen, total nitrogen, total sulfur. Well, this ultimate analysis also determines the ash content of particular coal sample. So, let's start our discussion on the ultimate analysis by the measurement of total nitrogen. Well, the total nitrogen in ultimate gas analysis is the measurement of weight percentage of nitrogen present in the coal sample. Well, nitrogen is mostly found in organic fraction of coal. So, the organic fraction of coal includes the nitrogen. Upon combustion, this nitrogen is liberated and it's in the form of nitrogen oxide. Well, this nitrogen oxide reacts with water vapor present in the atmosphere and produces nitric acid. Well, this nitric acid is environment concern since it ultimately produces acid rain. So, we have to minimize this nitrogen content of coal. So, this was about the measurement of nitrogen. Now, let's move to the second measurement, and that is measurement of total carbon. Well, the carbon in the ultimate analysis is the measurement of weight percentage of total carbon that is being present in the coal sample. Well, fixed carbon from the proximate analysis that we have seen in the previous video, that is completely different value from the total carbon. If you have missed that proximate analysis, you can find that video in the I button. So, the total carbon includes the total organic carbon that is escaped during the combustion reaction in the form of volatile matter. So, the proximate analysis where we measure this carbon percentage does not include carbon present in the volatile matter, while this ultimate analysis total carbon include that carbon present in the volatile matter. So, when coal is combusted in combustion, this carbon is liberated as the carbon dioxide or as the different hydrocarbons such as methane, ethane. The total carbon measurement may include carbon from mineral such as CaCO3 as well as organic fraction of coal. So, the total carbon also include carbon present in minerals such as CaCO3 and different organic materials. So, this was all about the total carbon. Now, let's move to the next measurement, and that is of total hydrogen. Well, the hydrogen in ultimate analysis is the measurement of weight percentage of total hydrogen that is being present in the coal sample. During the combustion reaction, hydrogen is liberated in the form of water vapor, which can come from the organic compound in the coal or inherent moisture that is present in the coal. So, there are two sources of hydrogen. One is the organic compound that is present in the coal itself or the inherent moisture present in the coal. Value of total hydrogen are used to calculate the amount of oxygen needed for the efficient combustion in the boiler. So, the amount of hydrogen tells us the amount of oxygen that will be required for the complete combustion of coal. So this measurement of hydrogen is very important again. Well, it also tells the material balance in the coal conversion process, such as gasification and liquidification. So for the material balance point of view, the total hydrogen is again very important, as it informs or it tells about the different processes, that is gasification and liquidification. So this was all about the hydrogen content. Now let's move to the sulfur content. Well, the total sulfur in the ultimate analysis is the measurement of weight percentage of total sulfur that is being present in the coal sample. The test, a coal sample is grounded to set size and weighted, then placed in the sulfur analyzer. So what we do is, we take one coal sample and we reduce its size to particular set size and weight it, and then we place this sample in sulfur analyzer. Well, in this sulfur analyzer, this sample is combusted at temperature around 1370 degrees Celsius in the presence of oxygen. So this oxygen is reacted with sulfur to produce sulfur dioxide. So this sample is combusted in the chemical reaction and it is allowed to react with oxygen in order to produce sulfur dioxide. Now this gas is then passed through an absorber detector in which the analyzer which measures the concentration of sulfur. So the product of this combustion reaction is allowed to pass through one absorber detector where we detect the sulfur compounds or measure the concentration of sulfur. So this is how we can measure the component of sulfur. The total sulfur is important because sulfur combined with oxygen in boiler and it produces sulfur dioxide. Well, this sulfur dioxide is then react with water vapor present in the atmosphere and produce sulfuric acid. This sulfuric acid is again the environment concern because it ultimately produces acid rain. So we have to minimize this sulfur content of fuel. So this was all about the total sulfur content and the ultimate analysis. Well, this ultimate analysis is very important for the exam point of view. It combinedly with proximate analysis asks for 7 marks. So better you prepare both the analysis of coal. Now let's move to the next topic of this chapter of energy efficiency in thermal utility, and that is steam system. Well, this steam has been most popular mode of conveying heat energy in process industries. Well, this steam is also utilized for generation of power or electricity. So this steam is very important for chemical engineer. This steam is utilized for transferring heat energy from one point to another point, and it also utilized to generate electricity. Well, there are certain characteristics that make this steam to most popular, and these characteristics are high specific heat and latent heat. Well, steam has the highest specific and latent heat that we can utilize for space heating or for process heating application. Well, the high heat transfer coefficient also make this steam as a most preferable source. Well, this steam is easy to control and it is easy to distribute this steam in different component or different equipment. And lastly, this steam is cheap and inert material. So now let's understand different properties of this steam so that we can utilize its maximum potential. Well, it is necessary to understand the properties of steam since it helps in designing of equipment and piping system. So in order to design equipment or network of pipe, this understanding of steam property is very essential. It also allows us to make the decision affecting the energy use of the system. So now let's see what are these properties. Well, first property of this steam is specific volume. Gases occupy less space at the under the pressure, but at lower pressure they occupy larger space. This means 1 kg of steam occupy different volume under different pressure condition. So the term specific volume refer to the volume that 1 kg of steam occupy at given temperature or pressure. So what does the specific volume means is the volume occupied by the steam at given pressure or particular pressure. Its unit is meter cube per kg. Now let's see the second property of steam, and that is quality of steam. Quality of steam, in a simple word, denote the mass of dry steam in given steam. So the quality of steam represent what amount of the dry steam is present in the steam and what amount of the different vapor water. In other words, how much vapor water is present in the steam. So it denoted by X, and it can be found by capital M divided by capital M plus small m, where capital M is nothing but the dry steam and small m is the water vapor. So someone says that the quality of steam is 80%, that means 80% of steam is in the form of dry steam, while remaining 20% is the water vapor. So this was all about the quality of steam. And the next property is the enthalpy. Well, the enthalpy is the quantity of heat required to rise the temperature of 1 kg of water from 0 degrees Celsius to its boiling point or saturation temperature at corresponding applied pressure. So what this enthalpy of steam means, it tells the amount or quantity of heat required to rise the temperature of 1 kg of water from 0 degrees Celsius to its boiling point at normal pressure, it is 100 degrees Celsius, or the saturation temperature. Well, we can find this enthalpy as delta H is equal to specific heat into the change in temperature or rise in temperature, which is again equal to 4.187 into delta T. Its unit is kilojoule per kg. So this was all about the properties of steam, and now let's see what is the steam distribution system. Well, the steam distribution system is essential link between the steam generator and steam user. So this distribution of steam is the link between the application of steam and the production of steam. That means where the generator produces the steam and where we are utilizing this steam for different purposes is being connected by this steam distribution. An efficient steam distribution system is essential if steam of right quality and pressure is to be supplied in right quantity to the steam using equipment. So efficient steam distribution system is always required, or it is essential to deliver the correct quantity and quality of steam at particular temperature or pressure for its application point or its necessary equipment. Here in this image you can see that we are using boiler to generate steam. Well, this boiler transfer this steam or distribute this steam to many equipments. Here the main line of steam is sent to different pans that utilize this steam, and then it sent to the different reactor for the heating application, and lastly it sent to the space heating application. While the secondary line you can see is sent to the different dryer where we dry the different products. So this was all about the steam distribution. Well, the steam generated in the boiler must be conveyed through piping network to point where its heat energy is required. Initially there will be one or more than one piping system that termed as the steam mains. Here in the image you can see that the top line that is coming out of the boiler here in this image is the steam line or main steam line, which then distributed into two sub line. One is going to the different pan and reactor, one is going to the space heating, and another one is going for the dryer application. So here what we are saying is smaller branch pipe can then carry the steam to individual pieces of equipment. The distribution pressure of steam is influenced by number of factors, but here we are limiting them for the two. One is the maximum safe working pressure of the boiler, and another one is the minimum pressure required at the plant or at the application. So now let's see what is the steam leakages. Well, steam leakages are the source of energy loss and must be avoided. So here in this image on the top of the screen you can see that the steam is leaking from its distribution channel. So this must be avoided because it shows the energy loss. Well, it is estimated that 3 mm of diameter hole of pipeline carrying 7 kg per centimeter square steam would waste around 33 kiloliter of fuel oil per year. Steam leakages on high pressure stream are prohibited. They are costlier than the low pressure steam leakages. Well, steam can be leaked from piping network, valve, flange and different joints in the process. The plant should consider regular surveillance program for identifying leakages at pipeline, valve, flange and joints. So we need to identify or we need to inspect the plant for the minimizing of the steam leakages from piping or valve or different flange and joints. Well, indeed, by plugging all the leakages, it ultimately results in the fuel saving. So if we stop or we restrict these steam leakages, we can ultimately save our fuel. Now let's see how we can restrict these steam leakages by means of steam trap. The purpose of installing steam trap is to obtain fast heating of product and the equipment by keeping steam line and equipment free of condensate, air and non-condensable gases. So what we do is we provide one steam trap which essentially block the steam and allow different condensate, air and non-condensable gases out of it. So a steam trap is valve kind of a device that discharge the condensate and air from the line, but it does not allow steam to go through it. There are basically 3 main functions of this steam trap, as to discharge the condensate as soon as it forms. So the condensate is formed, this steam trap will discharge or escape this condensate. Well, this steam trap does not allow steam to escape. That is its second most application or function. To discharge air and other non-combustible gases is also one of the main function of this steam trap. So now let's see what are the different steam trap are available. Well, there are 2 different type of steam trap. One is thermostatic and another one is the mechanical steam trap. Well, in the thermostatic steam trap, it operates by changing in the temperature of fluid. So whenever there is a change in temperature of fluid, this steam trap work on the principle of temperature. The thermostatic trap will sense the low temperature of condensate and pass it. When steam reaches the trap, the temperature increases and the trap closes. So when there is a low temperature condensate, this thermostat trap sense the low temperature and allow this condensate to escape through it. But when high pressure steam reaches the steam trap, the trap sense the higher temperature and it does not allow steam to go through it. Now let's see the mechanical type of steam trap. It operates by changing in the density of fluid. So it works on the operation or on the principle of the density. This steam trap includes ball float trap. Here in the image top of the screen, you can see that one typical example of mechanical steam trap, where we are utilizing the ball in the floating arrangement. So when the ball will rise in the presence of condensate by opening the valve and pass it. When steam reaches the trap, valve get closed because of its low density. So when this condensate will reach the ball will lift it up and this condensate allowed to escape through it. And when this steam reaches the ball sends the low density of steam and does not allow to escape steam from it. So this is how typical steam trap works. Well, this concludes this video. We will see you in next video. Till then, keep watching, keep learning. Thank you.